In this lecture, we will learn about the factory method design pattern and how to implement it in Python. The factory method design pattern is a creational design pattern used to define an interface for creating an object. It lets subclasses decide which class to instantiate. Factory method promotes loose coupling. It eliminates the need to bind application-specific classes into the code. When do we use the factory method pattern? It should be used when we don't know beforehand the exact types and dependencies of the objects your code should work with. We use the factory method pattern when you want to provide users of your library or framework with a way to extend its internal components. We can use it when we want to save system resources by reusing existing objects instead of rebuilding them each time. Let's look at the pros and cons of the factory method pattern. Advantages of this design pattern are that it avoids tight coupling between creator and concrete products. It promotes the single responsibility principle, and you can add new types of objects without breaking existing code. The drawback of using this pattern is that the code may become more complicated, since it adds a lot of subclasses. Let's learn how to implement the factory method design pattern in Python. First, we will create a class named playingCard, inside of which we'll have a type variable initialized to an empty string, and a suit variable initialized to an empty string. After that, we will create a class named HoylePlayingCard that extends the playingCard class. Inside of this class, we will implement the init function that takes in three parameters: self, value, and suit. Inside of the init function, we will set self.type equal to Hoyle, self.value equal to value, and self.suit equal to suit. Next, we will create a class named CongressPlayingCard that extends the playingCard class. This class will have an init function that takes in the parameters self, value, and suit. Inside of the init function, we will set self.type equal to Congress, self.value equal to value, and self.suit equal to suit. Then we will create a class named CardFactory. Inside of this class, we will define a getPlayingCard function that takes in the self parameter. For the function body, we will simply use the pass keyword, and the concrete classes that extend this class will implement it. Next, we will create a class named HoyleFactory that extends the CardFactory class. Inside of this class, we will define an init function that takes in three parameters: self, value, and suit. Inside of the init function, we will set self.value equal to value and self.suit equal to suit. Then we will define a getPlayingCard function that takes in the self parameter. Inside of this function, we will return a HoylePlayingCard object with self.value passed in as the first argument and self.suit passed in as the second argument. After that, we will create a class named CongressFactory that extends the CardFactory class. Inside of this class, we will define an init function that takes in three parameters: self, value, and suit. Inside of the init function, we will set self.value equal to value and self.suit equal to suit. Then we will implement the getPlayingCard function that takes in the self parameter. Inside of this function, we will return a CongressPlayingCard object that takes in self.value as the first argument and self.suit as the second argument. Time to test our code. We will create a variable named factory set to an initial value of none. Then we will create a card variable set equal to the input function with the string enter the card type you would like to create passed in as the prompt. If card.lower equals the string Hoyle, then we will set factory equal to HoyleFactory with 5 passed in as the value and spades passed in as the suit. Elif card.lower equals Congress, we will set factory equal to CongressFactory with 10 passed in as the value and hearts passed in as the suit. Then comes a variable named playingCard set equal to factory.getPlayingCard. Finally, we will print the type, value, and suit of the card. Let's run the code. We will be prompted to enter a card type. I will type Hoyle and then hit enter. As you can see, a new HoylePlayingCard was created. For the purposes of this example, we just created one card with each of the factories. I think this more basic example gives you the idea without boring you. In a real-world programming scenario, you may have to implement a factory that can create any of the 52 playing cards from a standard deck. In the next lecture, we will learn about the prototype design pattern and how to implement it in Python.